With a contrast or a mean comparison, really you're simply assessing whether two means or two groups are significantly different from each other. But significance can mean many different things based on the type of adjustment or decision rule that you're using. In statistics, there are many different decision rules. For this unit, you're going to learn about Tukey, Bonferroni, and Chaffee. They're really doing the same thing. They're just comparing two things, two means, but their cutoff or their decision about significance are slightly different from each other. And again, this is why it's really important to understand if you have post hoc comparisons or planned comparisons, because some decisions are more conservative than others. Now, since at this stage in the worksheet we have post hoc analyses, we can either use a Tukey adjustment or a Chaffee. Now, you really can only do Tukey if you have balanced groups. Again, that simply means the same number of participants in each group, which we do have here, so we can go ahead and do a Tukey adjustment, or you could decide to do a Chaffee. Now, a Chaffee adjustment is going to be the most strict, so it's best to use when you have unbalanced groups. And again, just to reiterate, when I say most strict, I'm really meaning it's harder to have a significant difference. On the other hand, if we had a priori hypotheses, we might decide to do a Bonferroni adjustment. Bonferroni adjustment, when you aren't making too many comparisons, is going to probably be the least strict. So it's really good, really well suited if you have a priori hypotheses or planned comparisons. Remember, a planned comparison can only happen before you even start collecting any data. I always find it's a little difficult to demonstrate that in a class like this because we're always working with data that already exists. But just know that with an a priori hypothesis or a planned comparison, that's really something that you have to decide before you even collect any data. And for that reason, it doesn't have to be as strict of a decision or as strict of a cutoff compared to a post hoc analysis. So we'll be demonstrating both today, but first let's go ahead and move into some post hoc comparisons. So going back into Stata, we're going to demonstrate two different ways to do comparisons or contrasts. The first will be the command pwmean. Simply stands for pairwise mean. Now, it'll be important to remember in the future that this can really only do what are called simple comparisons. So that's simply comparing two different groups. In the future, we'll talk about combining groups and do more complex contrasts. This is going to be, this is considered a simple contrast, where we're just comparing two means to each other. And this command will also do all possible comparisons. Right, so we have three levels, which means we can make three comparisons. And the command is pwmean, the dependent variable miss, over feedback. Right, and then you'll follow that by mcompare, stands for mean compare, and we're going to do the Tukey adjustment. Okay, you could do either Tukey, Chaffee, Bonferroni, whatever you put in the brackets there. That's the type of adjustment that Stata will be making. Okay. Now, importantly, this is what's called a post-estimation command. So just like with assessing residuals and regression, you can't do this command until you've actually fit the model. Right? So if you try to run this command before you fit your ANOVA model, I don't think it'll be able to work for you. Also, if you don't include the mcompare, you won't actually get the significance level. Right, and the great thing about Stata is whatever decision rule you're using or whatever type of adjustment you're using, Stata makes those adjustments for you. So behind the scenes, Stata is actually adjusting the p-value so that we can always compare it against a p of 0.05. All right, so we get a lot of information from this output, but really the only thing you'll have to report will be the t-statistic and the p-value. So this first column is telling us what comparison step we're actually doing here. So in this case, we're comparing groups 2 and 1. So that's the criticism group and the praise group. Groups 3 versus 1, so that's the control group versus the praise group. And then 3 versus 2, that's the control group versus the criticism group. And the contrast column, that's simply the mean difference between the groups. Here, it doesn't really matter whether it's positive or negative. That's simply a function of how Stata did the subtraction. So for this first row, Stata subtracted group 2 minus group 1. So the criticism group, or group 2, had a mean of 7 missed shots, whereas the praise group had a mean of 4.5 missed shots. And the reason that the last row is negative is just because group 3, which is the control group, had fewer missed shots compared to group 2, but it subtracted group 3 minus group 2. Again, it doesn't really matter whether the contrast column is positive or negative. And same with the t statistic. It doesn't matter if the t statistic is positive or negative. All right, and then finally, we have a column for the p statistic, or the p-value. Again, we're always going to compare this against 0.05. Unless otherwise stated, it's safe to assume that 0.05 is going to be the cutoff. In coming weeks, we'll talk about when that needs to be adjusted, but for this week, for right now, 0.05 is going to be our significance level. So we can see that this first row, this first comparison, is definitely significant using a Tukey adjustment. The mean for group 2 is significantly different from the mean from group 1. The p is less than 0.001. Remember that when Stata prints out a 0, that doesn't actually mean exactly 0, it's just less than 0.001. So group 2 is significantly different from group 1. Now, the next comparison is a little trickier. The control group versus the praise group. We have a p-value here of 0.051. And now the decision as to whether this is significant or not is a little bit trickier. And it really depends on how you round your decimals. If you round it to 2 decimals, you might say that the p equals 0.05, and therefore it is a significant difference. But if you round to 3 decimals, you would say the p is 0.051, and therefore a non-significant comparison, or marginally significant. This is why the standards in psychology are really moving towards rounding to 3 decimal places. Now, for consistency for this practical, we'll round to 2 decimal places and conclude that the praise group, group 1, performs significantly different to groups 2 and 3. Right, but we're really not done here. We need to know which group performed better. Now that we've done our comparisons, now that we've done our post-hoc comparisons, we can determine or conclude which group performed better than the other. And to do that, all we have to do is look at our means. All we have to do is look at the means and conclude from there. So if we scroll all the way back up, we can see that group 1 had the fewest missed shots, or the fewest missed baskets, so they performed significantly better compared to the compared to the criticism group and compared to the control group, or the no feedback group. Now for this exercise, let's go ahead and assume that we had some a priori hypotheses. So I'm going to go back to the worksheet. All right, and we're going to do step 4 of the worksheet now. In step 4, we both learn about how to handle a priori hypotheses, as well as another way to perform the mean comparisons. So now going back into the worksheet, let's say that instead of just comparing the different feedback styles, the researchers actually believed the coaches who argued that criticism improves performance of athletes. This would be considered an a priori assumption, or an a priori hypothesis. And that hypothesis would be that criticism improves performance compared to praise or no feedback at all. So the alternative hypothesis might be worded in such a way that states that the criticism group will have improved performance compared to both the praise group and the no feedback group. Now, again, I really want to reiterate that an a priori hypothesis or planned comparison has to be decided before you collect any data. Okay, so let's say as researchers, we decided that we have this hypothesis, so we know we're going to make the comparisons between the criticism group and the praise group, as well as the criticism group and the no feedback group. Okay, and we're specifically hypothesizing that the criticism group will perform better compared to the other two. And again, because we've decided this ahead of time, we can use a slightly less conservative adjustment. And that would be the Bonferroni adjustment. So in this unit, whenever you have a priori hypotheses, you know you're going to use a Bonferroni adjustment. Okay, in journal articles, you might see it done a little differently. There's really, it really might be journal dependent or even lab dependent. But for the sake of this unit, you know Bonferroni is most appropriate when you have a priori hypotheses. So we're going to go ahead and do the pairwise comparisons a little bit differently. Stata behind the scenes is really doing the same thing as it did above with the PW mean, but we're just using a slightly different command. Okay, so we're going to use the command one way, the dependent variable miss, the independent variable feedback, and then comma Bonferroni and Chaffee. So this will give us all of the possible comparisons using a Bonferroni adjustment, as well as all of the possible comparisons using a Chaffee adjustment. And we're really only doing this so that you can see the difference in the significance levels for the Bonferroni and the Chaffee. All right, so let's switch over into Stata again, and we'll run that command. Now you should see that the ANOVA table is exactly the same. The F statistic is the same as the command that we did above, 9.77, and it's of course significant. Right, and then next we have the comparisons for the Bonferroni adjustment as well as for the Chaffee adjustment. The output looks a little bit different compared to the last command that we ran, but it's still, essentially telling us the same thing. But really, we're only getting the contrast or the mean difference, as well as the p-value. We don't get the t statistic here, but that's okay. Really, the most important thing for a mean comparison is the p-value. Right, and we have the comparison between groups 1 and 2, groups 1 and 3, and groups 2 and 3. As we saw above, group 1, the praise group, is significantly different compared to the group 2, the criticism group. However, it's contradictory to our hypothesis. Remember, in the worksheet, we hypothesized that the criticism group will perform better compared to the praise group. And in this case, we're actually seeing the opposite. But it's probably not surprising to any of us as psychologists that only receiving criticism will actually will not improve your performance. Right, now with the Bonferroni adjustment, we actually have a non-significant comparison between groups 1 and 3. Whereas the Tukey was pretty borderline, and we actually concluded that the comparison was significant. In this case, in the Bonferroni adjustment, it's a non-significant comparison, or it's a non-significant difference. So you can already start to see how the significance levels are different based on the type of adjustment you're using. And in fact, in this case, the Bonferroni adjustment is slightly more strict compared to the Tukey adjustment. Now the results are consistent for the comparison between group 2 and 3. They're non-significant. This is a non-significant difference. And we can compare these results to the results of the Chaffee adjustment, which is the most strict or the most conservative estimate. When using a Chaffee adjustment, the comparison between groups 1 and 2 is still significant. However, you'll notice that it's slightly higher p-value compared to both the Tukey and the Bonferroni. So now the significance level is 0.001, whereas above it was less than 0.001. Right, we can also see the same thing with the mean difference between groups 1 and 3, the praise group and the control group. The significance level here, or the p-value, is 0.064. So both the Bonferroni and the Chaffee adjustments are concluding that the mean difference between groups 1 and 3 is not significant. All right, and then finally, again, groups 2 and 3 are not statistically different from each other. So what this is saying is that if a coach is criticizing a player consistently, it's really no different than giving no feedback at all. Now we can wrap it up and write up our conclusions. Let's go ahead and say we did not do the Bonferroni and the Chaffee adjustments. Let's say we stopped at our Tukey adjustment, and we'll interpret from there. So when you're writing up your results, it's really important that you not only maintain APA formatting or APA guidelines, but that you're consistently using the language of your research question as well as your variables. So we first want to report the results of the one-way ANOVA. So we might actually say, based on the one-way ANOVA, there was a significant difference in performance as a function of feedback type. And you report your degrees of freedom, the F statistic, and P is less than 0.001. We performed 3 post-hoc comparisons using a Tukey adjustment and found that the praise group, with mean of 4.5, standard deviation 1.27, performed significantly better than the no feedback group and the criticism group. All right, and I'm just reporting the p-value from the Tukey comparison. Finally, there was no significant difference in performance between the no feedback group and the criticism group. So I hope this helped clear up the difference between a planned comparison and a post-hoc comparison. Again, they're really doing the same thing. We just have to make more strict decisions based on whether the hypotheses were made beforehand or whether we're doing the comparisons after we collected the data. In the coming weeks, we're going to be demonstrating Factorial Anova, which is really an extension of one way. We just have multiple independent variables. And we're also going to demonstrate some more complex contrasts. So if you have any questions about this worksheet, be sure to reach out to your tutor. All right, and have a good week.